All right. Hey there, Jeffrey. Thanks for joining today's class. So let's get started with our regular procedure here. If you didn't complete homework, that's totally fine. We'll do it together. We'll actually just start off with that right now. So here is the first question for today's homework. It says you have $16 and a coupon for $5 discount at a local supermarket. A bottle of olive oil costs $7. And how many bottles of olive oil can you buy?
3.
All right, so pretty straightforward, pretty simple answer right here. With these questions though, even if you can get the final answer, that's great. Let's see if we can solve this algebraically. So how would you solve this using algebra, using variables, whatever?
Mhm. So I think the equation is in parentheses 16 plus 5 um um div divided by 7 equals like blank, I guess. So like a variable, I guess.
Sure. Okay, so 16 plus 5 divided by 7 equals, and we set a variable, so we'll just say, I'll just say A for now. All right, so what would A represent? So let A represent, what would it mean?
A is the amount of bottles, I think. Yeah, it's the amount of bottles.
All right, so the amount of bottles. All right, so solid answer right here. Not too bad. Now, typically, we would try to avoid using the variable as um, whatever everything's equal to, but it still makes sense here. Still totally fine. Um, one bottle is $7, $5 discount. Uh, yeah, I guess everything's fine. Everything works out. So having your final answer as I believe you said 3 is totally fine. So it's going to be 21 over 7 equals 3. Sorry, equals A, and then 3 equals A. All right, so pretty simple, very straightforward. Let's check out this question as well. So two college friends rent an apartment. They have to pay the landlord 2 months of rent and $500 security deposit. When they sign the lease, the total amount that they pay the landlord is $2,800. What is the rent for 1 month? So how would we solve this? What's the first step?
Okay, so you do 2800 minus 500, so it's 2300, and then you divide that by 2. So the total rent is 1150.
All right. So
All
what
right.
was that first step again? You said 4,800.
Um so you subtract 500 from 2800.
Oh, 528. Okay. And that ends up being 23, it looks like. And what was after that?
After that, you, okay, after that you divide it by 2.
All right. So simply divided by 2. Perfect. And that equals, I believe that's correct. 1150. Yeah, looks all right to me. All right. So this would end up being our, just for the sake of labeling everything, this is our 2 month rent um, cost, I guess. And here, cost of each month. Yeah, so I guess these questions are pretty simple. They don't really involve too many steps. So maybe for next time, for next week's homework or so, I'll try to include some problems that have longer steps. Like these ones are meant to be challenging. They're part of our challenge section. So the homework, I'll also make it a little challenging as well. All right, so moving on. Our first challenge question. A car rental company charges a fixed daily fee plus a fee per kilometer driven. John rented a car for 3 days, drove it for 150 kilometers, and paid $210. Sarah rented a car for 5 days, drove 300 kilometers, and paid $370. So what is the final question here? Okay, so we got to figure out what is the
Oh,
fixed
I got
daily
it.
fee and the fee per kilometer.
I got it. Cause I just was doing it in my head and I was kind of doing like guess and check, but my first one was correct. So it's each day costs $20.
All right.
And then each kilometer is just $1, I think. 5 days.
Can you say that again? So what was the daily fee?
Wait, never mind, it's incorrect. It only works for the first one.
Okay, no problem. So I'll just say this information for now. So the fixed, whoops, this should be per. So the fixed daily fee is what we need to find, and the fee per kilometer is another thing that we need to find. So what else do we know so far? What do we know?
That that John drove for rented the car for 3 days and drove for 150 kilometers, and he paid $210. And Sarah rented it for 5 days and drove 300 kilometers and paid $370.
All right. So a lot of different values going on here. I'm just going to put them all in the same line. So John's important values are 3 days, 150 kilometers, $210. Similarly, Sarah is 5 days, 300 and 370. So we don't really have any other information here. Let's work with this. So what we got to do is we got to figure out how can we represent this algebraically. So each person's situation, we have John and Sarah. How can we represent their payment situation using algebra? So let's go with John first, okay? Oops.
Okay. So I guess you say like 3 something, so like 3 D plus 150 I guess K equals 210. I
All right.
guess.
Yep. So you said 3 something plus 150 also something?
Yeah.
All right. Not too bad. So good start so far. And then equals 210. Perfect. So this is absolutely what we're looking for. One of the easy ways to go about this is to figure out two things: the units that we're working with, and also figure out what is the total. So for John, we're trying to think of what is the total value that he's dealing with here. And we can say that the total value would be the total money that he spent. So $210, that's total. So put that on the right side of our equation. So we figured out our total. He's on the right side and it's all alone. We figured out the unit as well because 210 is money. So we're going to work with money. We're going to work with dollars as our unit. Now, how do we figure out each of these, turning this into the same unit? So we're working with kilometers, for example, here. How do we turn this into dollars? We just multiply every kilometer by a dollar, whatever dollar, to figure out that there is a fee per kilometer. And similarly, figure out that there is a fee per every day that you're using it. So that would be another different variable over here. And let's do the same thing for Sarah. What is her equation?
Okay. Sarah, her equation is 5x plus 300y equals 370. Hi.
5x, 300y, 370. Perfect. Very well done. Now, using these two equations, how do we solve, or sorry, what is the next step?
Okay, the next step, I guess, would maybe like to be like make it so that only one variable is there, I guess.
Yep, excellent.
But I kind of don't know how to do that.
All right, yeah, no problem. So um let's see. So I want to look at John's equation first. 150y equals 210. Let's see if we can simplify this a little bit. So, okay, so looking at all these numbers here, we have 3, 150, 210. Can we simplify those numbers?
Yeah.
All right, so how would we do that? What would that look like?
But what are the numbers again?
So we're looking at John's numbers. So these numbers right
Okay.
here, we've got 3, 150, and 210. Can they be simplified?
Can you like make them? They're all divisible by like 3.
Yep, excellent. So what would that simplified version look like?
1x plus um 50y equals 70.
Excellent. Very well done. And since we have a simple x by itself over here, let's isolate that. That would be x equals 70 and bring the 50y over. That's going to be negative 50y. Yeah, so this would be our first equation that'll help us out. We have two variables, and we're going to need two equations. So we got both equations down. Let's shift this over. All right. So what is the next step? We have enough information here to solve our solution. What do we do?
Okay. Um. So now we know that like the daily fees probably $20. Oh, no, the daily fee's not $20. Because it was, well, actually, no, it is $20. Yeah.
Sure. Okay, so how did you figure that out?
Because I subtracted 50, I guess I subtracted 50 from each side.
50 from each side. So are you talking about this equation?
Oh, no, like the one before that.
This one?
Yeah.
So if you subtract 50 from each side, it would have to be 50y because this one is going to be a plus 50y. So if you subtract 50y, then that'll be canceled out. So you get that out of here. But whatever you do to one side, you got to do to the other side. So 70 minus 50y, that doesn't really solve anything for you yet. You don't have enough information yet. We just end up here. We just have minus 50y over here. And let's say you did minus 50 instead. So this would turn into 20. But this would not be removed. Nothing happens to this. It just ends up being x plus 50y, and then minus 50 is added onto here. So nothing's really being changed if we add or subtract 50. We've got to do a different step instead. What would we do?
Okay. Maybe try to get rid of the y.
Sure. We can try getting rid of the y. We do have to keep one variable though. So if we already got rid of the x, like we're trying to isolate for the x, let's just keep it as it is. What I want to do here is because we have two variables involved, we have an x and a y, we're going to need two equations to solve this. So here's one equation. We have x equals 70 minus 50. Why? What is the other equation?
Maybe x plus 50y equals 70.
So the other equation can't be the same thing, Like that's essentially the same thing that we're working with right now. The other equation is the other bit of information that's given to us. So this basically is John's equation. We just rearranged it. So the other equation is Sarah's equation. So
Oh,
let's just grab Sarah's equation and put it over here. Equals 370. All right, so now we have both equations that we need. What do we do here? If we're going to be working with these two equations, how do we make how do we find the value of one of these variables?
I think we gotta simplify Sarah's equation, maybe.
We don't have to, but if you want to, we can. But we don't have to. I don't think we can actually. We would have to divide everything by 5. Oh yeah, we could. We technically could, but it wouldn't really make too much of a difference here. So theoretically, with any type of question that involves solving two variables using two equations, you would have to sub one equation into another. So here's how I learned it. You can call this guy A and call this guy B. So you can just sub A into B. So what does that mean? That means you take B, so just write it out completely. And then you take, what is A? A is X equals something. So you find your X and you just change that X. You replace that X with the new X value. So we figured out that X equals 70 minus 50y. So let's just replace the X with that information. And everything else remains the same because there's no other X's. So here is our new equation. So does that make sense so far?
Yep.
All right, so now we have a much easier equation to work with. Only one variable, we can solve this. So how do we solve this equation?
Maybe use the distributive property.
Yep, for sure. So what would that look like?
350 minus um 250y.
350 minus 250y. All right, and yeah, everything else remains the same. Okay, so what is next? What do you do after?
So next you do 250 plus 300 y, which is 550y.
Sorry, 250 plus 300.
Yeah.
Okay, so we've got to do the negative, right? So it's going to be negative 250 plus 300. So that's going to be 50. And what about the other side?
What about the 350 though?
Yeah, so that 350, we can move them over. You can go over
Oh,
here.
370 plus 350.
Not quite. It's not going to be plus. So we're
Oh,
going to change the sign, right? So it's going to be 370 minus 350.
so 20.
Yep, perfect. So yeah, this should be pretty simple. We got 50y equals 20. What does y equal?
What? It's a decimal.
Yep, that is correct. It's going to be a decimal. So what is that value?
Oh, you have to do that by dividing like 20 divided by 50, right?
Yep, perfect. So 20
Just
divided by
simple.
50. You can say 2/5, or you can say 0.4. All right, so we got one of our values completed. We have y equals 0.4. Now let's do the next value. So we have y, we need to find x. How do we use y to find x?
Okay, I'm back.
Yep. Okay, so I was just saying we have the y value now. Now we need to find the x value using y. So how do we do that?
Okay. You find the x value using y. I guess you just like sub y into like the first. No, you just like wait, y is the day the kilometers. So I guess now that you know the kilometers, you can just like do like maybe like okay. So if the kilometers is okay, it's 40 cents. So you would do for like John, you do like um 150 times 0.4 times
150 times 0.
0.4. So it's
Okay, so
60.
you're gonna sub them into this equation right here?
Yeah.
All right, sure, no problem. So you can sub it into any of John's equations. You can do this, or you can do this, also known as equation A. We call it equation A, but either one is fine. So let's do the one that you said, the original equation. So we got 3x plus 150 times 0.4 equals 210. So what is 150 times 0.4?
61. Oh
All
no,
right,
60. Not
60.
61.
Which one is it? 60 or 61?
60. I misspoke.
All right, no problem. And then we got 210. How do we solve for x?
For okay. For x, no, because that wouldn't work. What if you move 60 to the other side then?
Yeah, that's correct. We'll move 60 over. That's 210 minus 60.
The 150?
Yep, very good. I'll just write 150 right here. And x equals,
50.
excellent. 150 divided by 3, x equals 50. Perfect. So we got our y value, we got our x value. Let me just highlight these guys. Now, if you want to double check, if you want to make sure that these are the correct values, you can plug them into the same equation at the same time. So for example, I will put them into equation A. So to confirm the correct values, sub x and y into A. So we got equation A is x equals 70 minus 50y. X is 50, and 70 minus 50y, y is 0.4. Whoops. That's going to be 50 equals 70 minus, what is 50 times 0.4? 20?
Yep.
And that's 50 equals 50. All right, so we're good. Everything works out. Our x and y values are correct. So the fixed daily fee is the value of x, so that's $50 per day. And the fee per kilometer is the value of y, which is $0.4 per kilometer. All right, very well done. So any questions with how we solved this question?
Nope.
All right, so I do want to show you another solution that we could do. So let's just take out all this right here. So this information is fine. We can keep this. I do want to change the next step. So instead of doing x equals 70 minus 50y, equation A, equation B, all that kind of stuff, instead of doing that, we can line up our two equations on top of each other. We'll do that right here, actually. Just to compare each equation, let's just stack them on top of each other and look at them and analyze them, right? So here's one equation, here's the other equation. They both have the same format, right? We both have coefficient x, coefficient y equals a whole number. So far, so good?
Yep.
So because they follow the same format, we can, let me write this down. We can, I'll say manipulate one of the equations to cancel out some terms. So it sounds a little funky, but let me put that over here. If we can manipulate one of these equations, either the top one or the bottom one, we can figure out how to cancel out one of these terms. So what I want to do here is I want to figure out which one is easier to cancel out. Can we cancel out x between each of these, or can we cancel out y between each of these? Like, which one's going to be easier?
Probably y, because we did it last time.
Yeah, so that is correct. Y is correct, so we can cancel out y. How would I need to change these equations to make sure that y can be easily canceled out?
Wouldn't be simplifying, right? Would it be simplifying?
We wouldn't necessarily simplify it, but we'd try to see if we can match the terms to each other so that we can cancel them out. So, if I said, for example, if x equals 10x at the top and 10x at the bottom, they cancel out. So they're the exact same term. We can cancel each other out. We can subtract them from each other. So is there a way that we can make any of these terms the same as any of these terms?
Okay, so same as the other. Can't, I already said simplify, but that's wrong. Oh, like as the other terms on top, right?
Yeah.
Would you divide?
Sure. So which one would you divide and how much?
Maybe divide all of them by 3?
Divide by
Oh,
3.
you said
Okay.
divide them by 3. No, that would be simplifying. Never mind. Oh,
So you're on the right track. You would have to do one operation like division. But in this case, we'd actually have to multiply instead. And what we can do here is we can take this first equation and multiply it by 2. So multiply by 2, and that would look like this. We got 6x. So we just take each term, multiply by 2. So 3x times 2 is 6x. 150y times 2 is 300y. And 210 times 2 is 420. So does that make sense so far?
yep.
All right, so multiply those guys by 2. The bottom equation stays the same. Now let's look at these two equations. Is there anything that we can cancel out?
There's 2 300s.
Excellent. So these two can cancel each other out if we just subtract them from each other. So basically what we're going to do is we're going to take equation A and subtract it by equation B. So we're going to do this. A minus B. What does A equal? 6x plus 300. Okay, yeah, we'll leave it like this. 6x plus 300. And then this is going to be 5x plus 300y. And then it's going to equal both right sides. It's going to equal 420 from equation A minus 370 from equation B. I know it looks a little funky, it looks a little complicated seeing which parts go where, but it's essentially we're just taking the entire equation and multiplying it by this entire equation. Did you see how I did that so far?
Yep.
All right, excellent. So now let's simplify this equation. So how do we simplify this?
Would you start with like finishing the other side so you can make it like 50?
Yeah, okay, so 50 is going to be the other side, right side. What else? What is the left side going to look like?
You cancel out both 300s.
Yeah, you can. So there is a step before that, distributive property, right? So let's get that down here.
Where would you have to oh, wait.
So right here, this minus sign and everything inside this little bracket. So that's going to be minus 5x minus 300y, right?
I'm not, I think.
So we got this minus sign, right? And then that's going to be multiplied by each term inside of this bracket. So it's going to be minus times 5x, so that's minus 5x. And then minus times 300y, which is minus 300y. Does that make sense?
Yeah.
All right, so now we end up with 6x plus 300y minus 5x minus 500y, sorry, 300y equals 50. What is the next step here?
The next is okay, so you have, can you rearrange it to like where you like are subtracting, like instead of like maybe you make it like 6x plus negative like 5x.
Yep, plus negative 5x is the same as minus 5x.
So 1x.
Yeah, for sure. Let's rearrange the other guys too. So we got 300y, whoops, forgot the sign, plus 300y minus 300y equals 50. So that's 1x, or just simply x, plus 300y minus 300y. Those guys get canceled out. So that equals 0. And then the right side is 50, so x equals 50. So we got our x value. That's already done. Now, to get y, we just sub it back into one of these formulas. So you can just sub it into the same one that we already did. I forgot which one we did already, but whatever. I'll just choose this one. So now we can sub x into one of the equations to solve for y. So x equals 5 times 50 plus 300y equals 370. That is 250 plus 300y equals 370. How do we solve for y?
But we gotta solve for this one too.
Yeah. Well, it's going to be the same answer, but yeah.
Maybe move the 250 to the other side.
Yep. Perfect. So 370 minus 250, that's 120. 120? Yeah, 120. Y is going to equal 120 minus 3, or over 300.
That's 50. Wait, no, is that 50? No, it's not.
Let's simplify that. So we can break it down to 12 over 30, and then that can be broken down into, can we divide this by 3? So 4 over 10, 2 over 5. 2 over 5, 0.4. So we get the same answers again. We get x equals 50, y equals 0.4. Everything is the exact same as last time, but we're just doing a different solution. So this time we're doing this step. We're canceling out terms. The other time we are subbing in a value into another. Both solutions make sense. They both find the right answer at the end, but it's just a matter of which one do you prefer. So because this, because these equations are formatted the exact same way, and they can easily be canceled out just by multiplying the first one by 2. That's why I wanted to bring up this solution. It's not like it's not impossible to do. You can definitely identify this with future equations, but either one works. The first solution works as well. So if you're comfortable doing the first method, by all means, keep doing this. If you have this method in your back pocket, that's great too. Both of them work. Are there any questions with either of these solution methods?
Nope.
All right, so let's take on another word problem here. This one's dealing with percentages. Mark spends 60% of his salary on rent and groceries. His rent is 3 times his grocery expense. The remaining 40% of his salary is $1,200. Write and solve an equation to find his monthly salary, calculate his rent and grocery expense. So, a lot of information here. Let's write down what do we know.
Okay, so he spent 60% of his salary on rent and groceries. His rent is 3 times his salary, and the remaining 40% of salary is 1,200.
All right, so rent equals 3 times his groceries. So let's just say R equals 3G. And the remaining 40% of his salary is 1,200. All right, so 40% of salary equals this. Oops.
Okay, so I mean, I kind of think I know what to do. I guess I would divide the salary by 4, so because it's 40%, so it'd be 300, and then 300 times 10 is 3,000. So I know his full salary is 3,000.
All right, so we take this, divide by 4, that equals 300. And what is this? What's the purpose of finding this? What does this represent?
To find 100% of his salary.
To find 10%.
Oh yeah, 10%. Yeah.
All right, and what did you do after that?
300 times 10 to find 100%.
All right, 300 times 10 equals 3,000. This is 100% of salary. And then?
And then, so now we know his salary, but to find the rent and grocery expenses, we do 3,000 minus 1,200, which is 1,800. And then we divide his 1,800 into 4. And here, I need to use a calculator for that. 1,800 divided into 4 parts is 450. And then so we know that the rent is so the grocery bill is 450, and then the rent is 1,800 minus 450.
Yeah, or you can say 450 times 3 because we know rent is 3 times the grocery.
So that's 1,350.
And that's rent. Okay, so we got his rent, we got his groceries, we got his monthly salary. I think we are done here. Yeah, I think we're done. Looks good to me. So in terms of the actual values that we got, the values are all correct. 3,000 makes sense of his total salary. 450, 1350, those make sense. Those are correct. Now, the only issue here is we solve this logically. This makes sense. Let's actually see if we can communicate this algebraically. So let's see if we can throw some algebra in here, use some variables, create some formulas to say like, sorry, not formulas, equations to say this equation represents salary, this equation represents groceries, blah, blah, blah. So the solution is fine, but let's make this algebraically. So the first step is using what we know. Can you break that down into some algebraic expressions? So this portion right here, can any of this be broken down into an algebraic expression? So I did one so far. I did R equals 3G. Is there anything else we can do?
I think we have to do it for like the 40% salary thing. So maybe like, 1,200 times like, oh, times two. Yeah, no, it's isn't it times 2.4 equals blank?
1,200 times 2.4 equals blank. Okay, so remember, when we have a final number, like a total number, for example, that's going to be on our right side. So what I can do here is if we're trying to represent the 40% and 1,200, if we're trying to represent that information into an
Never mind.
algebraic
It's
expression,
actually 2.5. I checked. It's wrong.
what's 2.5?
It's not 2.4. Well, actually, you won't even know how much to multiply by. All you know is like, it's 40%. So
All right. So yeah, back to what I was saying. 40% of his salary is 1,200. We can keep the 1,200 as the right side of the equation. That is the total. And if something is 40% of something else, we can write this down pretty simply. We can say 0.4, which is 40%, times our salary is 1,200. So salary is our variable. Salary is going to be S. So 0.4S equals 1,200. Now, let's use that same logic to figure out the 60%. So 60% of the salary equals something. What is that expression going to look like?
for the 60%. Okay. So for finding out the salary, right? The total salary, correct?
So we're doing these 60% of the salary is equal to rent and groceries. So we're only using this highlighted portion, and we want to figure out what does this look like if we make it into an algebraic expression.
Well, no, it's still R equals. No, no, it can't be. So I guess total salary. So S divided by 0. No, times 0.6.
Okay.
I guess.
Yep. So far, so good.
Equals R and G. R plus G.
All right, perfect. Excellent job. So this is absolutely correct. So here's one equation, here's another equation, and our final equation. Excellent. So let's use those three equations to solve this entire formula, this entire solution. So you got one down correct. The first step was to solve for the salary. So find the salary. So what is S equal? We figured that out with the combination of these two steps. So I do want to point out one thing. You made this into two steps. You can combine them into one step. So you see how you did divided by 4, and then you did times 10. You can just make that into one step right there. So what is something that you divide by 4 times 10? That's going to be the same as divide by 0.4. Does that make sense?
Yep.
All right, so we can do S equals exactly what you wrote, 1200 divide by 4 times 10. So divide by 4 times 10, which is the same as 1200 divided by 0.4, which gives us 3000. Excellent. Now, let's copy paste this, put this over here. So we got S equals 3000. What is the next thing that we can solve? So using this information, it looks like this is our next step. Now we're going to do the 60%. So how do we solve this? We can sub S into this formula. We can do 0.6 3000 equals R plus G. 0.6 times 3000, what does that equal?
1200.
Not quite 1200.
Wait, 0.6
Yep.
times 3000?
Yep.
0.6 times 3000. Oh, I actually put in 300, but I guess that works too. 1800.
Excellent. 1800 equals R plus G. So we're stuck here. We have two variables. We can't do anything. But if we have another equation, then we can solve this, right? So two variables, two equations means that we can solve the question. So what is the second equation that we can do to help us solve this? This is
Maybe
our first equation.
Oh,
So I'll give you a hint. The other equation is on the page. It's somewhere in this highlighted section.
nope. Would it no, it wouldn't be rent, right? It wouldn't be like the 3 times 450 equals one 1350, right?
So we're getting there. So that is the correct information that we need. We need to know the values for rent and groceries, but we can use this instead. We can use something that has variables to help us cancel out other variables. So I'm going to sub in R equals 3G. So sub in R equals 3G. So we'll do 1800 equals R plus G. So we know R equals 3G, so we can do 3G plus G. Now that equals 1800 equals 4G. So that series of steps right there, does that make sense to you?
Yep.
All right, excellent. So now we are left with a simple operation. G equals 1800 divided by 4. We already finished that on the other side. That equals 450. Perfect. R equals 3G. So R equals 3 times 450, which is 1350. Yeah, I think that's it. We got every value that we need. Yeah, we're done. So that is correct. So G is this, R is this, and our formula is up here. Oh no, S. That's what we needed. S equals that. Okay, so I'll highlight that as well. All right, excellent job. So a lot of different steps involved here. So you already solved this pretty well. Actually, you solved this perfectly using like a more logical approach. It's correct, totally fine. But because we're trying to deal with algebra, that's what the point of these questions is. We have to make sure that we can represent this situation using algebra. So try to practice that, try to make that into a habit of, first of all, taking what you know, representing it using variables, and then working from there. All this knowledge right here that you provided is perfect. And all this stuff, we actually ended up using it in each solution. So it is very helpful and very much on track. Just make sure that you start off with algebra so you can apply these steps using the variables and all that. Any questions with how we solved this entire solution?
No questions.
All right, nicely done. So let's move on. Let's shift gears to a little bit of geometry as well. So here is a pentagon. We have interior angles for the pentagon, but three of them are represented using a variable. We have x plus 29 degrees, x plus 35 degrees, and x plus 43 degrees. So essentially, we just need to find x. So how do we solve this? What is the first step towards solving this equation? Or not equation, but diagram.
Okay. So I don't know. Wait. So are we trying to find x?
Yeah.
Okay. Okay. So I'm not sure what to do here.
Yep, no problem. So very similar to our previous questions about interior angles of triangles. So let's say, for example, if I had a triangle of angles, um, let's say, I don't know, 70, 40, and x, how do we find the value of x?
We add up 70 and 40, so 110,
Yep,
and then you subtract that from 180, so it's 70.
excellent. So we find the sum of the angles that we do know and subtract that from 180. But where'd you get 180 from?
Isn't that the total for triangles?
Perfect. So 180 is the total of a triangle. We're dealing with a pentagon. So what is the total interior angle of a pentagon?
Um, one isn't it 180 times 3? So
Yeah,
540?
yep, very good. Very good. Excellent job. So interior angle sum of pentagon equals, and we're going to say 180 times 3, which is 540. All right, now, knowing this information, we know that 540 is the total sum of the angles. What is the next step? How do we solve for x?
Do we have to create an algebraic equation?
Kind of. So you know how you did right now, 180 minus the sum of angles equals x. We can kind of do the exact same thing here. So we can do, uh, actually, no, never mind. Ignore that bit of information. This one's a little different. We can just add up all these angles to make it equal 540. So that's basically the answer. That's how we solve this. We just add everything up and we find for x, everything equals 540. So let's write that out. Let me just stretch this out a little. So we got our first angle 77 plus 143. Then we got x plus 29. We got x plus 35. And x plus 43. All of that equals 540. So now, how do we solve for x?
Maybe get rid of the 77 and 143.
For sure. How do we do that?
Bring them to the other side as a tap.
All right. Excellent. So let me just put this guy over here. 540 minus 77 minus 143. All right. And let's just figure out the right side first, make it easy for ourselves. What is the right side going to equal?
320.
Excellent. 320. Now we got to play around at the left side. How do we simplify that left side?
What, the right side?
No, all the left side, all these brackets and x's. How do we simplify that?
Maybe you can use guess and check.
Let's try not to use guess and check. Let's try to actually solve this using some, whatever math that we already know. We can definitely do it. We basically just have to get rid of those brackets.
Maybe distributive property,
Yep.
but there's nothing.
Distributive property can help, but nothing's going to change. You're right. Nothing will change. There's no negative signs. There's no numbers, nothing like that. So we can simply just get rid of those brackets. So we can just do x plus 29 plus x plus 35 plus x plus 43, 320. And what do we do after that?
Maybe add up all the x's, so 3x.
Perfect. 3x. And what's next?
Okay, 3x plus 29. Okay, add up all the other numbers. So, what are the numbers?
29,
29,
35, and 43.
35, and 43. Oh, it's 29. Okay, so then plus 6. That's 107.
Excellent. 107. Got 320 over here. And how do we
Move
solve for x?
107 to the other side as subtraction. So, 320 minus, oh, that's 213.
Perfect.
And 213 divided by 3, 71.
Excellent. 71. So x equals 71. And so, the question is just to find x. If they wanted you to find each individual angle, you just say this angle equals 71 plus 29. This is 71 plus 35, and so on. But this is correct. X equals 71. That's perfect. Do you have any questions with how we solve this question?
Nope.
All right. Excellent. So that is it for today's class. In terms of homework, you can do this one.
Okay.
And try to solve this algebraically, though.
Got it.
All right. And the other question, I'll just type it out for you. Let's take this out. Give me a sec here. All right. Here it is.
Okay. Here, I'll take. Okay, I got it.
All right, excellent. So it's just these two. But yeah, that's it for today's homework. Great stuff today, Jeffrey. We'll continue with these topics next week. Do you want me to add anything else to our lesson?
So far, no. Yeah, no.
All right, perfect. So I'll just continue with these topics. I'll just make them a little more creative and tricky. I'll see you next week. Take care.
Bye. Thank you. Have a good day.
Thanks. You too.
Bye.